G'day. Today's clip is a bit of a repair story. Usually when I go into places that deal in second-hand machinery, I'll look around and see whether I can find anything that's something I'm looking for. And I went into one the other day and found a couple of drill bits. But the trouble was that the tang on the back was chopped off. Now, the problem with that is that if you put the sleeve on, or have it into a shaft like a drill press shaft, you can't lever it off with the drift. So today's video is basically how you can repair those sorts of things. It's not difficult. Probably the most difficult part is getting a light touch with the grinder just to dress that back to the surface of the taper and not gouge away. These are the drill bits in question. This is a number 2 Morse. It's a 22.5mm diameter drill, and as you can see, the tang is much shorter than it should be. So it's been cut off, broken off, whatever. There's a little bit of twist there which makes me think it's been broken off. This is the number 1 Morse. Similarly, you can see that the tang is a lot shorter than it should be. What's the tang on a drill bit for? Well, basically it's to help eject. There is some arguments about this. Everybody says no, it's to help drive the drill, but it basically goes into the socket, and then using a drift like this you can pop it out. It's not meant to drive, so when you see something like this one, and I'm assured that this is not an SKF drill bit by the local SKF rep, when you see something like that, it means that hasn't gripped in the taper, it hasn't seated. And so what's happened is when the torque has been applied to the drill, it's just twisted. So really all the tang is doing is allowing you to eject the drill from the socket, and so it doesn't have to be anything particularly hard or anything like that. It just has to be long enough that when you put the wedge in, it will pop that out. Just as an aside, most lathe tailstocks, when you wind them right back, there will be a pin that comes forward and knocks out the taper, so you don't have to worry about things like that for ejecting taper drills with a tang on them. But this is my my normal live center, and it hasn't got a tang on it. Now, to eject that, I've made up this little device. That's just a stop, and that just slides in like so. And so if I then wind that back, so that contacts the ring around the taper there, that pushes the center out. Worth thinking about, particularly if you've got centers like this where there's nowhere that you can put something in there to pop that out. When using one of these bits in a drill press, I have a lump of aluminium which I put on the table, so when I slide that into the taper, I can press down on that just to try and seat that drill a little bit better. You can use a block of aluminium, maybe a block of hardwood if you've got something that's going to just provide some pressure there, just to seat that up. Now, looking at that doesn't look all that flash anyway, so it may be that this drill hasn't been gripping, but once I've got the tang repaired, I'll have a look at that and see whether it's worth polishing that up or remachining that to get the taper back. I've made up my replacement tang. It's just a little bit of steel milled out to the appropriate size. The sizes for these things are dictated by standards, and in the back of a Zeus book there are tables for Morse taper shanks complete with tank dimensions and all that sort of thing, so that's what I'm using. What I'm now going to do, I've got my collet holder set up in the mill here. I'm going to put the drill bit in and put a bit of a slot in there so I've got something to anchor that replacement tang in. I've got a collet holder set up in the chuck here. I'm just going to eyeball that in. I'll come in, I'll just put a little bit of a rebate there so that I've got a locating piece for my replacement tang, and then I'm going to just very carefully TIG weld that either side and dress it up, and it should be good as new. As I said previously, I've eyeballed in the angle of this to get the slot I'm putting in roughly corresponding with the old tang that was there. I actually used the DRO to set the height here just touching off on the top with the bottom of the blade, touching off the bottom with the top of the blade, and doing the half thing. And then there's my replacement tang, which needs to go in away. The way I'm working this out is I have a Morse taper sleeve and I have a good drill bit, so I know that that comes to there, and I can measure from there to there, which is 74 millimeters. I can put that same sleeve on there, and that comes up to there, so I can measure from there what 74 millimeters is, take away a bit for this, I need to come in about 6 to 8 millimeters, and that'll be fine. I've put a bit of emery over this to try and clean it up a little bit because the sleeve wasn't going on, and as you can see it's in pretty poor state, but we'll worry about that at a later date, I think. I'm just about to start welding these up. I've put some corner relief on the tang blanks, and I've also done the same for my slots. That will fit in there like so, and then I can fill that and grind that back and not have to worry about grinding all my weld away. I don't need much there, just enough to hold it firmly. The sleeve goes straight on, so my sizing is about right, but I'll still need to get the top of that dressed. Properly when it's all together. If you worry about the heat from the welding affecting this bit, you can always try wrapping a wet rag around that. That will help. That'll take some of the heat out, but it'll things will still get warm. It won't solve the problem entirely, but I've got, what's that, about 8 millimeters of weld in 4 places, and it's not a very big V, so I don't need to put much material into there, so I should be right with this. So this is the Morse #1 taper. I've welded the tang in and then dressed that back. You can see there's a couple of gaps there where I didn't quite get in with the weld, but then again I didn't want to dwell too much before I destroyed the heat, destroyed the temper. As you can see, it fits, and that's the main thing. And if I tap that, that's not going anywhere. But if I put my drift in, I can get that apart. So that's what we want. If you're really concerned as to whether this was causing problems, get a whiteboard pen and just highlight the weld with a bit of whiteboard pen, put it in the socket, take it out, and that'll show you any high spots that exist. This is the #2. I haven't ground this one back yet, but weld down the sides there, a little bit across the bottom. This one I have done that, bit across there. I'll grind that to size, and there's no reason why that shouldn't be as good as that one.
Hope this has been of interest to people, and please remember to check the back catalogue for other videos that might also be of interest. Thanks for watching.